I have a circuit breaker project I'd like to present to you guys today, which involves Serial Peripheral Interface, otherwise known as SPI. And let me just brief you guys on the architecture of the circuit breakers first. These 3 bits essentially just select which circuit breaker I want to use. And this first bit right here, for each particular circuit breaker, selects whether we want it open or closed. 1 will mean open and 0 will mean closed in this case. As you can see, we have this pattern right here, just as an example. And down here, we have the SPI controller, which basically will have each circuit breaker state be loaded into each peripheral. And then we can write into this SPI and store all of the states accordingly. This is oftentimes used in relays for, circuit breaker monitoring. If we need to monitor the circuit breakers to make sure that everything is operating smoothly. And let me just get to the demonstration because I have something else in mind I would like to show y'all. So what we're first going to do is disable this because we don't want anything to be written into this output. We merely just want every state to be loaded into each peripheral first. So then when we turn the clock off and turn it back on, everything should be loaded into it. And as you can see, this is exactly what I wanted to show y'all. Even though we only have a 1, 1, and a 1 at the end of our circuit breakers, all of these are green because a tri-state buffer in each peripheral will cause any unselected peripheral to give an undefined output. And if we have a breaker peripheral selected, it'll just generalize essentially to the output of that particular breaker that is selected. So since we have the first breaker selected and the output is 1, it'll generalize to 1. Okay? And now what we can do is we can close the clock, we can enable it again, and boom. Now what we want to do is we want to select the next breaker, and then clock cycle, done. Another clock cycle, done. And essentially this can go all the way down to the 7th one. And I didn't include any sort of trip or any sort of overload or anything like that because that would have taken two memory units, D flip-flops, and I wanted just to keep the SPI functionality as simple and as robust as I could possibly get it. So while a trip would be more practical, I can include that if y'all suggest that you guys would like to see me include a trip functionality into it. Also, I had to go back up and down in order to select the next breaker. You can actually use you can use a 3-bit counter and automate that process by having a 3-bit counter to just simulate a clock cycle and just count through each of these without having to individually click buttons. And yeah, that's about it, really. And I just wanted to show y'all what a tri-state buffer kind of looks like. This always has to be enabled in order for this to not be undefined, as you see right there. And the same with the peripheral. Oops, there we go. But anyways, y'all, I hope y'all really enjoyed that. If any of y'all want to collaborate on any projects, just let me know.